Sodium is an element with the chemical symbol of Na. Its atomic number is 11, meaning that it has 11 protons and neutrons in its nucleus, as well as 11 electrons in the electron shells. As such, its electron configuration is 281, meaning that it is highly reactive due to its single valence electron wanting to go away in order to complete the valence shell. It is located on the first column and the third row of the periodic table. The column in which an element is located is determined by the amount of valence electrons. Sodium's singular valence electron means that it is in the first group of the periodic table. Sodium is also on the third row, and this is determined by the amount of electron shells that an element has. Sodium has 3 electron shells in order to store the total 11, meaning that it is on the third row. This puts sodium on the first column and the third row of the periodic table. Protons are subatomic particles with a positive charge. The amount of protons in an atom determines what element it will be. In the case of sodium, 11 protons makes it a sodium atom, and an atom with 2 protons, for example, would be a helium atom. In comparison to other atomic particles, it is the heaviest alongside neutrons, and in an atom can be found inside the nucleus. In relation to other subatomic particles, electrons' weight is minuscule. Electrons have a negative charge and float around the electron shells surrounding the nucleus. The amount of electrons in the valence shell, which is the outermost electron shell, determines how reactive an element is. For an element like sodium with one valence electron, it is highly reactive as the goal of each atom is to gain a full valence shell through losing or gaining electrons. In the case of sodium, losing an electron would achieve a full valence shell. Because each electron shell holds 8 electrons apart from the first one, which holds 2, elements with a number of valence electrons around 1 to 2 and 6 to 7 are highly reactive, as they will react with almost anything in order to gain a full valence shell. Neutrons have a similar weight to protons, and when conjoined with protons together in the nucleus, make up the majority of the mass of an atom. Neutrons have a neutral charge, meaning that they do not have a charge. Adding or taking away neutrons in an atom can change certain elements into different isotopes, depending on how many neutrons are present in the atom. All stable atoms have an equal amount of protons to neutrons, but if the amount of neutrons is increased or decreased, it can alter the weight and stability of the element, making it an isotope. Neutrons also hold together the protons in the nucleus by acting as a glue for the protons, as their positive charges would naturally repel one another. Isotopes and ions are special types of atoms. An isotope is formed when the amount of neutrons in an element changes, altering the element's stability. For example, adding 7 neutrons to a sodium atom will increase the mass and make it unstable. In unstable isotopes, radioactive decay will occur, releasing alpha, beta, or gamma radiation. An example of an unstable isotope is hydrogen-3, which has 2 neutrons instead of 0 in a normal stable hydrogen atom. When it is in this unstable state, it will eventually radioactively decay in an attempt to make it more stable. This will form a new element and a particle. With hydrogen-3, when it radioactively decays, the resulting products will be helium and beta particles, and it will now be stable. An ion is formed by gaining or losing electrons, changing the overall charge of the atom. An anion is a negatively charged ion, and a cation is a positively charged ion. Ions are formed by normal chemical reactions and will leave the reactants, depending on the reaction, as an ion. Metal atoms in a reaction will lose electrons and become positively charged cations, while nonmetals will gain electrons to become negatively charged anions. A common reaction involving sodium is the sodium and water reaction. When water and sodium come into contact, it is highly reactive and results in the aqueous sodium hydroxide and the gas hydrogen. I've written the word equation for this reaction, and I've put a 2 in front of the sodium, water, and the sodium hydroxide to relay the conservation of mass law, as the matter did not just disappear or appear. Balancing the equation in this way shows this by keeping the same amount of each atoms and molecules on each side. Chemical reactions occur when a reactive element either gives away, takes, or shares electrons with another element in order to gain a full valence shell.